All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you're going to want to do remove, replace, reduce. So remove the 25 by multiplying it by the 9, and that's going to give you x squared minus 30x plus 225. From there, you're going to factor x minus 15, x minus 15. Then you're going to replace the 25 in front of your x, inside of your parentheses. And then you're going to reduce. 25 and 15 both divide by 5. So you'll have 5x minus 3 times 5x minus 3. So you can write that as your answer. Or you can make it 5x minus 3 squared. Okay. For the math knowledge question, you're having 5 flags flown on a pole, and you have to order them from top to bottom. So we can put any of the 5 flags in this first spot. And then in the second spot, we've picked one of the flags, so we have 4 left. In the next spot, we have 3 flags that can be flown. In the next one, we have 2. And in the last one, we only have 1 flag that can be flown. So you're just going to multiply 5 times 4 times 3 times 2 times 1, or just 5 factorial. And so that should give you 120. So you can have 120 different messages from your 5 flags. Okay, so now we're going to look at lesson 23. We're looking at trig functions of n theta, and then we're going to look at graphing conics on a graphing calculator. We looked at graphing ones that were centered at the origin a couple of lessons ago. These are going to be ones that are not centered at the origin. It's the same concept, it's just going to be a little bit more in depth. So hopefully the trig function part is review from last year, and then the graphing conics is a continuation of what we've done a couple of lessons ago. So hopefully you remember there are 2 different angles where the sine is equal to 1/2 in between 0 and 360. 30 degrees in the first quadrant, and then 150 in the second quadrant. So we're going to use that information here. I'm going to get rid of this 3 theta, and I'm going to make it sine of x equals 1/2. So where does sine of x equal 1/2? Well, we just went over it equals it at 30 degrees and at 150. However, it wasn't asking us to solve for x. It was asking us to solve for theta. So I replaced 3 theta with an x. So I need to solve for theta. So I'm going to divide my theta by 3, which means I need to divide my x's by 3. So instead of having 30 and 150, if I divide by 3, I get 10 and 50. Okay, but I can have some other answers in there. And the way that we're going to figure those out, you always take 360 and divide it by the same number that you divided your x and your theta by. So we divided by 3, so 360 divided by 3 is 120. And then you're going to add that to each of these 2 answers. So 120 plus 10 is 130. 120 plus 50 is 170. And then you're going to keep going. So 130 plus 120 is 250. 170 plus 120 is 290. And you try again. And you stop once you get above 360, because that's our upper limit. So 250 plus 120 is 370. So we stop there because we got above 360. And so these are your 6 answers. You should definitely have done this last year in pre-cal, so hopefully that's a little bit of a review. Some of y'all may work it out a little bit differently, which is perfectly fine as long as you're getting those same 6 answers. Okay, so we're going to look at another one. Solve tangent of 4 theta minus square root of 3 over 3 equals 0. So the first thing you need to do is to get your tangent part by itself. So we're going to add the square root of 3 over 3 to the other side. And then I'm going to replace 4 theta with a variable. And you can make it whatever you want. It doesn't matter. I usually just use x. But you can use whatever you want. And you just need to make a note that 4 theta is the same thing as x. So what angles equal square root of 3 over 3? you're either thinking 30 degrees or 60 degrees. I'm going to go back to the triangle just in case some of y'all are not sure. And we have 1, square root of 3, and 2. The tangent of 60 is square root of 3 over 1. The tangent of 30 equals 1 over square root of 3, which is the same thing as square root of 3 over 3, because we just rationalized it. So 30 degrees is the one that you want to pick, not 60. Now for the other one, where else is tangent positive? Go back to your all students take calculus. Tangent is positive in the third quadrant. So what is a 30-degree angle in the third quadrant? Well, you go 180 plus another 30. That puts you at 210. Okay, but I'm not going to continue in degrees just yet because it says we want it in radians. And so if we go ahead and change these to radians, it'll make it a little bit easier to get your final answer. So 30 degrees in terms of radians is pi over 6. And 210 in terms of radians is 7 pi over 6. So we're going to change it to radians just so that it makes it easier to get all of our answers, rather than getting them all in degrees and then having to change all of them into radians. You can do that. I just find it's a little bit more time consuming. All right, so we're going to divide by 4 here to solve for our theta. So pi over 6 divided by 4 is going to become pi over 24. And then 7 pi over 6 divided by 4 is going to become 7 pi over 24. Okay, and then we took 360 and divided by 4, but for this one we're using radians, and 360 is the same thing as 2 pi radians. So we divide it by 4, and that is pi over 2. So that's what we're basically going to be adding to this one. And since they're in 24, I'm going to make it 12 pi over 24, just so that it's easier to add. So if we add to the first one, we're going to get 13 pi over 24. If we add it to the next one, we're going to get 19 pi over 24. If you add it again, you're going to get 25 pi over 24. If you add it again, you're going to get 31 pi over 24. We add again to get 37 pi over 24. We add again to get 43 pi over 24. And you may be wondering, how do I know when I get above 2 pi? Well, 2 pi, if we make it over 24, 2 times 24 is 48. So we're looking once we get above 48 pi over 24. So if you add 37 plus 12, you're going to get above 48. And so these are your 8 answers that you will get. Okay, so that's hopefully a review from pre-calculus. You do have to have all 8 of those to be able to get your answer correct on this problem. If you have half of them, congratulations, you got half of them, but it's still wrong. And on your test, whenever I'm grading them, I would put to dictate not and what, but that you're missing 4 of them. That's usually what I would do. Okay, so we're going to look now at graphing this ellipse on the graphing calculator. So we have to solve this equation for y. So we only have one y term, and it's right here. So we're going to move everything else to the other side. So we're going to have 15 minus x squared minus 2x. Divide by 4. And since none of these are evenly divisible by 4, I'm just going to leave it as one term. So we have 15 minus x squared minus 2x all over 4. And to get rid of the squared on the y, you take the square root. And so y would equal plus or minus the square root of 15 minus x squared minus 2x over 4. You can make this over 2 by pulling the square root of 4 out if you want to. Either one of those would be fine with me. It does not matter. Okay, so we're going to graph y equals, we're going to do the square root of 50, I need to do parentheses, 15 minus x squared minus 2x, close parentheses, divided by 4. Okay, and then for the other one, we would do negative square root, and I'm going to do the second option here for this one just so that you can see it. 15 minus x squared minus 2x, and then get out of the radical and divide by 2. And so if you go graph it, that's what it looks like. And I'm going to change my window. I'm going to zoom out a little bit. So I'm going to hit 3, and it zooms out and it makes that. So that's the ellipse. Okay, so that's how that works. We're going to look at another one that's a little bit more complicated. What is different about this one? Hopefully you're noticing that there are 2 y's, and so we can't just eliminate the x squared and the 4x by moving them over and taking the square root, because we've got 2 different y terms. So what you need to do is to complete the square to put it into standard form. So we're going to do x squared plus 4x, leave a space and put close parentheses, and then y squared minus 2y, leave a space, close parentheses, equals 4. So half of 4 squared would be 4, because half of 4 is 2, squared is 4. Half of negative 2 squared, half of that would be negative 1 squared, would be 1. So we just added 4 and 1, so we're going to add 4 and 1 to the other side of the equation. And then this would factor as x plus 2 squared plus y minus 1 squared equals 9. You should have done that last year in pre-calculus. That's putting it into almost standard form. Normally you would divide by 9 to make this term over here a 1. We're not going to do that though, because we're trying to solve for y. So from here, I'm going to keep this term by itself. So I'm going to have 9 minus x plus 2 squared. And then from here, I'm going to take the square root of both sides of my equation. And so I'm going to have y minus 1 equals plus or minus the square root of 9 minus x plus 2 squared. And then I'm going to add 1 to the right side. And I'm going to put it in the front, just because that's how I prefer to write it. It doesn't matter where you put it though. Okay, so those are the 2 equations that you would use to graph this one. So if you go to your graphing calculator, you can go back to y equals, and you're going to do 1 plus the square root of 9 minus x plus 2 squared. And then the other one is going to be minus the square root of 9 minus x plus 2 squared. Okay, and then if you go graph it, it's supposed to graph an ellipse. And it does. Again, notice that it doesn't quite complete the ellipse. That's okay. This one doesn't look like an ellipse. So if you want to make it look more like an ellipse, go and do z squared, which is 5. And it still doesn't look very much like an ellipse, but that's okay. All right. So that's how you would graph ones that are not centered at the origin. Okay. Your homework tonight, you do get to omit 21 part A, but you need to use, or you do need to do 21 part B. So just skip the stating the identity, just go find it and use it for your part B part. Okay. So make sure to do your other 20 some odd questions tonight for homework so we can go over them tomorrow.